Okay, for the second part, they are looking, I want to back this up just a little bit. They're looking at, whoops, different organisms that are in a possible food chain. Okay, and so this is what their worksheet looks like. And so they should be looking at this. We're looking at the nitrogen levels, and we've talked about how they go up as they accumulate in your system. So they should be able to build a food web from this. And so they should look and say, okay, who's got the lowest amount of nitrogen? They're probably at the bottom of the food chain. And you can see that this guy's really low, this guy's really low, this guy's really low, this guy's really low. Whoops, I missed one. Okay? And so that gives you an idea of maybe that they're at the bottom. And then you look, okay, do we have sort of another cluster of organisms? And we do. We have this guy, and this guy, and this guy. And do we have another cluster? Well, yeah, that's about 3 points up in the 12s. We've got this guy, and we've got this guy, and then we've got the morin that's just way up there all by himself. Okay, and so they should know from the fact that it accumulates up the food chain that we can put these guys in that order. Okay, so we've got Pilfred, and Jopper, and Druster, I don't know where I came up with these, and Lancelip down here. And then above them in the food chain, we have Criffin, Biop, and Gringset. And then above them in the food chain, we've got, where am I? Fallenloper, and Ellentop. And then at the very tip top of the food chain, we have morin. Okay, so they should draw this on their papers, and it also asks them to illustrate their creatures so they can have fun drawing their little organisms, whatever they look like. Reminds you of where the wild things are. And so when you get this up there, though, you're going to draw one big one up on the board, and then you're going to explain and introduce a few terms. So first of all, you'd say, what kind of organisms do you think that these might be? Okay? And if they're tempted to say producers, like they're grass or plants of some sort, remind them that producers, plants and things, have 0. So they're going to be somewhere down here in this big, huge food chain or level underneath. So I'm going to put grass. Okay? And they would be effectively at 0, and these would be your producers. So these guys right here are actually your primary consumers. And then these guys would be your secondary consumers. And these guys would be your tertiary consumers. And then this guy would be your quaternary consumer. Okay, so now do we know who's eating who? We don't, but you might ask them, how might you find out who's eating who? Besides actually going and observing them in the wild, could we find out from their carcass or their remains or their fossilization or whatever? And the answer is yes. If we had their carbon values, we might be able to tell who's eating who, because your carbon that you eat should look the same as what you're eating. And then someone ate you, their carbon would be the same. It doesn't bioaccumulate like the nitrogen does, and so you would see matching. They're actually going to have to do that later on I think on the homework maybe. Okay, and so that's something to point out. But what you also might notice, and it asks them what they might notice about the biomass also, okay? So have them say, okay, what do you notice about the biomass? If we were actually to put in the biomass at each of these levels, so the morin has 0.8 biomass. If we add the Fallenloper and the Ellentrope, we've got 7 and 4, so we're about at 11. If we add these three together, we've got 42 and 48, which is 90, where's another one? 90 and 51, so we have 141-ish here. And then the last ones, oh man, we got 400 and 350, so that's 750, 1050, 1475. I hope I did that right. Okay, so that's what they should notice as biomass, and so they should notice that with each jump, Each jump is only 10%. We get 10% remaining of biomass. Now this is intuitive, right? That the farther you go up the food chain, the less organisms we can sustain up the food chain, right? We have lots and lots of producers, less consumers at the primary level, even less at the secondary level, less at the tertiary level, less at the quaternary level. And that's because energy transfer is not efficient. Okay, and they should have learned this when we did the energy labs with the food calorimetry, that, you know, that energy diagram that we draw. Okay, if we do a coupled diagram and we have our exergonic reaction, right, breaking down the food, and then we build up our ATP, it never goes up. Okay, it never goes up to the same level where it was before. We always lose a little bit of that energy, that much of it we lose to the environment. Okay, and so each energy level, as I consume, I only get about 10%, because 90% of it goes to building that organism and then lost to the environment. So I only get about 10% of what was there. And so it goes 10% each time. So there's only so far you can go up a food chain before there's nothing left. Okay, and we call these trophic levels. Troph being energy. Okay, so a heterotroph is somebody who has to eat something else for their energy. An autotroph is someone who produces it themselves. So a producer would be an autotroph. They get their energy from themselves. And then all of these guys would be heterotrophs. They get their energy from other organisms. Can you see that? Okay. All right, so that's part 2. And then I'm going to pause this and do part 3.